To yet another episode where we shall be looking at the proposed prediction of the June examination for the grade 11's mathematics 2025. Now, this paper is usually 100 marks. Okay, usually 100 marks, but it can also slightly go below that to 75, but usually 100 to 150. Okay, the duration in this case is going to be 2 hours. Okay. And besides that, there's basically 3 topics that will be tested. Number 1, we have what we call the analytical geometry. Okay. Analytical geometry. And then number 2, we have what we call the trigonometry. And then lastly, we have what we call the Euclidean geometry. Okay, so it's just these 3 topics that will be tested on based on the coverage that you guys have had. Okay, now I want us to go step by step through some of the questions that we've selected out, and let's guide you on how questions could be answered or approached. Okay, so instructions, we have 6 questions that we're going to answer. Okay, and then question number 1, which is the analytical. They're telling us that PQRS is a quadrilateral with these vertices. Okay, we have all that information within the diagram, and then they want us to determine the lengths. So remember, when they ask for lengths, that's basically the distance. So we need the length PS and RS. So 1.1, I'll say with my distance formula, we know that my PS is going to be the square root, okay, of x2 minus x1 squared plus y2 minus y1 squared. Now my focus is PS, so I can call this x1, y1, x2, y2, and then I'll just substitute into the formula. Okay, so x2 is -2 minus 5 squared plus, we have a -5 minus 0. This must be squared also. And then all I'll have to do is punch this into the calculator straight away the way it is. I don't need to break it down further. So it's saying it's -2. I'll say plus, we have, okay, so I'm getting square root of 34. So we prefer to have the answers as SADs. Okay, that's units. Okay, that's PS. Then I'll do the same with RS. Okay, this is RS. So if I call this X1 and Y1, and then I'll do the same thing. So I'm not going to write down the formula again since I already did that. So we said x2, which is a -2 minus a 3 squared, plus the y2 is a -5. We are subtracting y1, which is a -2 squared. Some people prefer putting the negative part in the brackets. It's not a big deal for as long as it's all indicated. Okay, so I'm gonna have that, come on, squared, plus I'm gonna have that, and then I'm also getting square root of 34. Okay, root 34. So this is a root 34. This is also a root 34. Okay, then they want us to get the coordinates of the midpoint of PR. Okay, so if we have this as our PR, we must get the midpoint. So midpoint is basically the point that is in the middle, the halfway of the line segment. So the formula of the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Please do not confuse the addition and of the midpoint and then the subtraction of the distance formula. Okay, so we're gonna say, okay, let me call this 2 and 2. Just label them, baptize them the way you want to. So I'll have a negative 5 plus 3 divided by 2. 0 plus negative 2 divided by 2. Okay. And then I'll simplify this further. It's going to give me a negative 2 over 2, which is a negative 1. That's also a negative 1. So this is my midpoint. It could probably be somewhere there. Okay. So they are calling this M. Then can we show that the value of T is 3 if it's given that PR and QS bisect each other? So in other words, if we have another diagonal, just like that, and then these diagonals are bisecting, meaning that M is the central midpoint for both diagonals, okay? So if this is a negative 1 and a negative 1, I'm still going to use the midpoint formula, okay? But what I'll do, I'll say the formula, I already wrote it out, show that T is a 3, yeah. So I'll only focus on this part of T, which is the Y aspect. So if I get a negative 5 plus the T divided by 2, I should get this negative 1, okay? And then do your cross multiplication, so negative 5 plus T should give us a negative 2, move the negative 5 that side, and then T becomes just a 3. Okay. Alternatively, since they're asking us to show that T is equal to 3, if it's given that by 6, all you can do, if you substitute this with a 3, try to get the midpoint. If it gives you that, well and good. That could also be an option. And then 1.4, they want us to get the gradient of PQ. Now, whenever we are getting the gradient, remember, it's the change in Y over the change in X, okay? We prefer writing it as Y2 minus Y1 over X2 minus X1. So focus is on PQ. PQ. So we already know that this is a 0 and 3. So we're going to say 3 minus 0. Okay, it is a 3 minus 0 over 0 minus minus 5. 0 minus minus 5. So this gives me a 3 over 5. We prefer leaving it as a common fraction as well, that is simplified. So the change in Y, which is 3, the change in X, which is of 5. Okay, then they want the size of PQR. P, Q, and R. In other words, they want us to get this entire angle here. How many marks is this question? It's 4 marks, okay. Now, there are 2 ways to do this, né? We can get the... Okay, I don't want to speculate, but I don't want to assume that it's a 90, né? I don't want to assume that it's a 90. Otherwise, I can use the inclination part, whereby I have the gradient here, so I can find this angle. And then I also can find the gradient of this line, and then I also get this angle, and then, yeah. Okay, so let's get the gradient of QR. Okay, so we're saying the gradient of QR. So we're going to use the same formula, change in Y over change in X. So this is going to be the Y2, which is a 3, minus minus 2. Okay, that's a 3 minus minus 2 over the 0 minus 3. Okay, this is 0 minus 3. So that's going to be 5 over negative 3. I told you. Okay. So if that is true, I can just see that these two are reciprocals. So I can just say that if I get 3 over 5 times 5 over negative 3, this gives me a negative 1. Therefore, PQR is a 90. Okay, the assumption kind of worked. Ne? But if you don't want to go that route, you can use the inclination. Okay, find the tan, the arctan of 3/5. What we get? Let's see, we're saying shift tan of 3/5. That gives me 30.96. Okay. And then the shift tan of negative, let's see. Okay, shift tan of negative 5/3. And then I'm plusing, okay, that's gonna give me the arctan of negative 5/3. I'm getting a negative 59.04. And then I have to plus 180 so that I can get the positive aspect, which is 120.96. If that is true, meaning that this is the 120.96, we say this is the 30.96, and then these two should be equivalent to this exterior angle. We subtract, very 90. All right, then 1.6, what type of quadrilateral is PQRS? Now we know that this is a 90. Okay, if that's a 90, we're seeing that this side is equal to that side. And chances are high that even these other angles are going to be 90s. Okay, so what sort of shape is this? It's going to be a square. Okay, I'm gonna call it a square. The reason, there's a 90 degree, and then we have sides that are equal. Okay, sides that are equal, and then the 90 degrees. Okay, question number 2, still under analytical. Okay, in the diagram below, A is -2, B is -2, -1, C is P, and -4. These are good vertices of a triangle ABC. Q is the x-intercept of the line AC. This is the angle of inclination, and then BAC is a 37. They want us to determine the size of theta. Determine the size of theta. Wow. What do we do? What do we do? Anybody? Okay. So since this theta is an exterior angle, I can just focus on this sort of triangle here. Okay. So what I need is for me to get this angle. I have this, I have that. So I can use the gradient to find the inclination angle, and then I plus the 2, and then I have my theta. Okay, so I'll say the gradient of AB, you said change in Y over change in X. So it's going to be 4 minus minus 1 over -2 minus minus 2. But wait a minute. If that is true, that this is a -2, which means it's going to be undefined here. So this gradient is undefined, meaning that this line is parallel to the y-axis. And if that is true, then this is a 90. Okay, so meaning that our theta is going to be 90 plus a 37, which becomes 127. Now I'm seeing -2 and -2 there. So yeah. Then calculate the equation of AC. The equation of AC. Now, since this is 127, remember this is a straight line. And the equation of a straight line must have a gradient and the y-intercept. We don't have the gradient. Let's get the gradient. So gradient of AC is going to be the tan of 127. If I substitute that into my calculator, I'm getting, can't I get a fraction? The calculator says no. Tan of 127. I'm getting negative 1,33. It's fine. I'll use that. I'll use the decimal. Okay, then I'll say y minus y1 is equal to m into x minus x1. So I can use this point A and say y minus 4 is equal to negative 1,33 into x minus minus 2. Then y is going to be negative 1,33x minus 2,66 plus 4. And then what's our equation? Negative 2,66 plus 4 is 1,34. So 1,33x plus 1,34. This is a negative. Okay, so that becomes our answer. Please, if you can have the gradient as a fraction, well and good. Can go ahead and give it to us. Then calculate the coordinate of Q, which is the x-intercept of AC. So we know that at the x-intercept, y is a 0. So we're going to replace y with a 0, and then we solve for x. So that's going to be 0 is negative 1,33x plus 1,34. Move that from that side, meaning that x is 1,34 over 1,33. This thing is more or less the same thing, 1,34 divided by 1,33, which is like 1,00, which is approximately a 1, because it's 1,07 and stuff. So I'll call that a 1. Okay. Then determine the value of P if A, Q, and C are collinear. So when points are collinear, simply means that the points lie on the same straight line. Okay. So if they're lying on the same straight line, there is just one aspect that connects collinear points, and that is the gradient. Meaning that the gradient from A to Q should be the same as the gradient from Q to C. So I'm not going to use the gradient that we found because it's sort of a decimal, but then 2.4 is being specific and say they want the integral, meaning that it should be more or less like a whole number value, okay, for P. So I'll say that the gradient of AQ, okay, gradient of AQ should be the same as the gradient of QC. Then we're saying the change in y over the change in x must be also the same as change in y in that case over the change in x. So it's going to be 4 minus 0, okay, over negative 2 minus 1 is equal to, we can have 0 minus minus 4. Let's have it the other way around, negative 4 minus 0, okay, over P minus 1. Okay, so let's simplify the left. That's a 4 over negative 3 is equivalent to negative 4 over P minus 1. Let's cross multiply. That's going to be 4P minus 4 is equal to 12. So 4P 16, meaning that P is going to be a 4. Remember, P is on the positive side of the X. All right, there we go. Then 2.5, they want us to get the equation of the line that is parallel to BC, okay, but passing through A. Now, when lines are parallel, what happens to the gradients? The gradients must be the same, okay? So what this question is asking us indirectly to do is get the gradient of BC, okay? So gradient of BC, we're going to have the change in y over the change in x. Looking at the coordinates, I'll say minus 4 minus minus 1 over 4 minus minus 2. So this gives me a negative 3 over, when I simplify that, I get a 6, which is negative a half. Good. Then I'm going to use point A, which is negative 2 and 4. Okay. And then I'll say that y minus y1 is equal to m into x minus x1. So I'm going to say y minus 4 is equal to negative a half into x minus minus 2. Let's open this up. It's going to be negative a half x. That's going to be minus 1 plus 4, meaning that it's negative a half of x plus 3. So that's what the question basically asked for. So that's how questions of analytical geometry can be answered. If you have an angle, you need the gradient, use that tan. If you have the gradient, you need the angle, still use that same formula, but in the opposite way, and then you end up with that. So this topic, we can guarantee full marks in this case, because usually it's a plus minus 30 marks, okay? So that we have 30 in the bag. Let's move on. Question number 3, trigonometry. So with the trig, we just need to remember all our aspects of the trig, okay, in as much as we also need to look at the graphs. But in grade 11, our main focus is the reduction. If we know how to do reduction, then we are good for the paper. Okay, so reduction, identities, and some bit of proofs. Okay, so we are being told that if theta is 89,4 and alpha is 122, can we evaluate? To evaluate is just find the exact answer. Round of answers correct to 3 decimals. They want us to get the sign of alpha. So this is a grade 10 question. So sign of 122. I mean, everyone needs to know how to use a calculator to get these values, because these should be free marks. So that's going to be 0,848. Remember, your calculator needs to be in the decimals, or degrees, sorry. It needs to be set in degrees. Okay. Then 2, we have the tan of alpha. So it's going to be the tan of 122 over the cos squared of 89,4 plus 122. So punch this in the calculator. Don't break it down. Where there is cos squared, you can just say cos of this whole thing times cos of that whole thing, or put it in brackets and then you square it at once. Okay, so we're saying we have the tan of 122. We're dividing it by, we're going to say brackets, cos of 89,4 plus 122. Close the bracket, you square it. Okay, what I mean is that if you don't want to put this, just have it like this, you square it. So this is going to be negative 2,197. That's what I'm getting. Let's see, let's just confirm it and see. Let's confirm it and see. This is 89.4 plus 122. Perfect. So this is the easiest approach if you're punching this in the calculator. Okay. Then 3.2. 3.2. We're being told that if 3 tan beta, now please and please, the beta here, actually we don't have a beta in the first question. Perfect. It has nothing to do with 3.1. If 3 tan beta plus 2 is 0, and then the sign of beta is positive, determine without the use of a calculator and with the aid of a sketch the following. Now, what happens? Let me write it this side. Say 3 tan beta plus 2 is equal to 0. Sin beta is greater than 0. So step number 1, start by drawing a sketch. But before we even get to the sketch, can we make tan beta the subject? So move the 2, so we're going to have a negative 2, then you divide both sides by 3. So we have something like this. Now, with the sketch, because it should be more like on a Cartesian, we need to know the correct quadrant where to place our sketch. We have 2 conditions. Number 1, we need a quadrant where tan is negative. So we have this quadrant, we have this quadrant, because the first and the third tan is positive. Okay, then we need to also use this condition. We need a quadrant where sine is greater than 0. This means that sine must be positive in that quadrant, and it's only quadrant number 2. So this is where we put our sketch. Just throw in a triangle in that format. Okay. Remember, they told us this is beta, which is just the same thing as that angle there. So tan is the opposite over adjacent. So it doesn't matter where this negative is. It can be on top, it can be down. So it's going to be a 2, this is going to be a 3. But we know that it is the 3 that will be negative at the end of it all, because this 2 is on the positive part of the y-axis. Then we need to use the theorem of Pythagoras to determine the missing side, which is the hypotenuse. Okay, meaning that our r is going to be the square root of negative 3 squared plus 2 squared. Okay, so what do we get there? We have 3 squared plus 2 squared from root 13. Okay, so we're getting square root of 13. Now, for as long as we're done with this, then we can go ahead and answer the questions. They want the cos of beta, cos of beta. Okay, cos, we know that cos is adjacent over hypotenuse, so it's negative 3 over root 13. Please leave it like that. Do not give us the rationalized form, because in that case, you would have used the calculator. Then root 13 cos beta minus 13 sine squared. So this is going to be like root 13 multiplied by the cos. Remember, cos, we said it's negative 3 over root 13. We are subtracting 13 times the sine. Now, sine is the opposite, which is 2 over root 13. Okay, we're going to have 2 over root 13. This is squared. Okay, so let's simplify that. This cancels that. We have a negative 3. And when you simplify that, we're going to have a 13 times 4 over 13. This cancels this also. So minus 3 minus 4, which is a minus 7. Okay, so that is how 3.2 would have been approached. Get those 2 marks, please. Then 3.3. If sine 4 is m, they want us to get the tan of 4 in terms of m. Okay, let me write it this side. So if the sine of 4 degrees is m, we must find the tan of 94. No, tan of 94 in terms of m. So still, how many marks it should be? 4 marks, because it looks otherwise. So it's 3. Okay, no stress. And so what is going to complicate this is this tan, because we know that tan is having an identity of sine 94 over cos of 94. This is the only challenge. If this wasn't the challenge, life would have been easy for us. But it's fine. Let's see how we're going to do it. So let's create also another sketch. Okay. And this sketch is going to be in form of a triangle. In this case, we don't care about the quadrant. Okay, if that is a 4, sine is opposite over hypotenuse. So m and 1. Then I need to find this other missing side using the Pythagoras. And that's going to be square root of 1 minus m squared. If that is done, then I can go down and break down the tan 94. We said it's going to be the sine of 94. I'm going to say 90 plus 4 over the cos of 90 plus 4. Let me reduce this. So sine of 94 is going to give me cos of 4. Because remember, if you have the sine of 90 plus theta is the same as the cos of theta. So that's going to be the sine of 4 over cos of 90 plus is going to give me a negative sine you are lying, bruh. This is a cos, then this is a negative sine of 4. Good. Then let's use our sketch. Okay, so with the sketch, we know that the cos is going to be adjacent over hypotenuse. So the root of 1 minus m squared over the sine, they told us it's m. So basically this is what they wanted. That is what they wanted. So when you're reducing this, remember these are complementary ratios. So they must switch. If it was a sine, becomes a cos. If it was a cos, becomes a sine. Okay, so that is how that question would have been approached for 3 marks. Then 3.4, which is the reduction. Okay, how do we reduce this? Now this is in the correct format. Correct format, correct format. This is a wrong format, which means we need to take out the negative sign. So if I'm to rewrite this, I'll have the cos of 360 minus x multiplied by the tan. I'll say negative 180 minus x, and then everything is over the sine of minus x, and then the cos of 90 minus x. Okay, let's reduce this and we see where we end. So 360 minus is in quadrant number 4, and cos is positive there. So I'll have a cos x. Okay. And then followed by 180 minus. So this negative can also come that side. So 180 minus is quadrant number 2, and tan is negative. So it's going to be negative and then a negative tan x. We're dividing it by the sine negative, can also be negative sine x. Okay, and then the cos of 90 minus is going to give us just a positive sine x. Okay, so what do we see here? So this is going to be a positive. So I have cos x. That means, okay, cos x multiplied by positive tan x. Just dragging these things to, this is sine x and then the sine x. Let me change the tan as much as I would have killed it long time ago. This is sine x over cos x. So we're dividing it by negative sine x and then a sine x. So this cos cancels this cos. And then I'm only going to be left with sine x over this. So this sine can cancel that. So we're left with 1 over negative sine x, or it could be negative 1 over sine x, either way. Okay, so the quickest format of killing this was going to be when you change this. We know that cos over sine is the cot, which is like 1 over tan. So that would have been tan x over tan x times the sine of x. This cancels, and then we're back to the answer straight away. Okay, so that is 3.4 with a reduction. Then 3.5, they want us to evaluate. Now, when you're evaluating, especially with numbers, it's possible that you're going to have some special angles. Chances are high, okay? Let's see. If we have tan of 120, we are multiplying it by the sine of 115. Then divide this by the cos of 240, and then times the cos of 205. Now, when ratios are next to each other, there's a multiplication. Okay, so let me go backwards just to show people how we're going to reduce this. So I'll try to use the long approach. So 120 is in quadrant number 2. In quadrant number 2, the angle format is 180 minus. So what do we subtract from 180 to give us 120? It's a 60. Then 115 is also quadrant number 2. What do we subtract from 180 minus 115 is going to give me 65. Alternatively, I could use a 90 plus. Ne? What's 115 minus a 90, which is also a 25? So I can say this is a 90 plus 25 over 240 is in quadrant 3, which is 180 plus 16. 205 is in quadrant 3, which is 180 plus a 25. Perfect. So the trick in this reduction is just to create similarity, especially with the angles that are not special. So we have a 25, we have a 25, which means life is somehow easy for us. All right, so from the top, in the second quadrant, tan is negative. So you're going to have negative tan of 16 multiplied by sine of 90 plus, that's going to give us a cos of 25 over cos of 180 plus, it's going to be a negative cos of 60. We're multiplying it by cos of 180 plus, that's a negative cos 25. Okay, so no one is going to give you marks for this step. Ne? The marks will come from here, this next step, the reduction part. That's where you're going to start getting marks. So we can cancel this and cancel that because it's just the same thing. Then we can use our special angles straight away. So what is the tan of 60? Tan of 60 is opposite over adjacent, so which means it's just a negative root 3 over this negative and a negative, we have a positive. The cos of 60 is basically a half. Adjacent over hypotenuse, perfect. And then when we simplify this, it's just going to give us negative 2 root 3 as our answer. Okay, so that's how one would have achieved those 6 marks. Ne? Then 3.6, prove the identity. So it's 1 minus cos x. Just something like that. Ne? Then plus 1 over 1 plus cos x. This should give us an answer of 2 over sine squared x. Okay. Whenever we are proving an identity, start with the side that has more information. So in this case, we have our left-hand side with a lot of information. The right-hand side just has one term, okay? Then on the left, we have fractions. So we're going to apply the knowledge of fractions to sort this out. And then when we look at the right-hand side, there is no cos. We only have a sine. And yet on the left, it's just a cos. So let's start. Let's use the butterfly method to kill these fractions. So that's going to be the whole of this multiplied by 1 is going to be 1 plus cos x plus this one. Then 1 minus cos plus that's going to be 1 minus cos x over. I was supposed to start by writing down the left-hand side. Okay, sorry about that. Then we are having a difference of 2 squares at the bottom. So it's like 1 times 1 is 1. Cos and cos, I'm going to end up with cos what? Squared x. Then from the top, this cancels this because the signs are opposite. Then 1 plus 1 gives us a 2 over 1 minus cos squared x. From that identity of sine squared x plus cos squared x equals to 1, if you move this one this side, we're going to be left with just the sine, meaning that this is the same as 2 over sine squared x, which is equal to the right-hand side. Perfect. So that is how this proof would have been killed. 3.7, general solution. Okay, so for us to get the general solution, what we need to do is aim at getting just one trig ratio so that you work with that. But then if that is not possible, then you'll have to do divisions or whichever format. Okay, if that's not possible, then factorization will have to do. But in this case, it's just a straightforward. We have just one trig ratio, which is the tan. So isolate the ratio. Make sure there's nothing around it. So you're going to divide both sides by 5. So that the tan of theta plus 10 should be equivalent to 4/5. Then we need to get what we call our reference angle using the arctan of 4/5. Okay, so shift tan of 4/5 is giving me some funny answer, which is 38.66. Okay, 38.66. Now remember, this tan is positive, and tan can only be positive in quadrant 1 and in quadrant number 3. So if I have my first solution, it's going to be the theta plus 10 should be equivalent to the 38.66 plus k multiplied by the period, which is 180. Then I'll have to move this 10 to that side, and this 10 only subtracts this, meaning that our theta is going to be 28.66 plus k times 180 is an element of integer. So this is just the first solution. Then in the third quadrant, the angle format is 180 plus. So 180 plus the 38, we're going to get 81. So it's a 218. So theta plus 10 must give us 218 plus k times 180. Move the 10, meaning that the second solution will be 208 plus k times 180. K is an element of integers. So this is what was needed for that particular question. All right, so that is question number 3. Then we move on to question number 4. Question number 4, which is the trig function, trig graphs. So if you're given f of x as sine 2x and g of x is 3 cos x, for x is between -90 and a positive 90. Sketch the graphs on the same set of axes. The given show the coordinates of the intercepts and the turning points. Okay, so we just need to use our calculators, okay, so that we can draw this. So step number 1, for people that are using Casio, the calculator. The calculators, you just have to press mod, okay, so it's a mod, and then look for the table format, okay, and then from table, we can enter our f of x, which is the sine 2x, okay, so we close the bracket, press the equal signs, and then if your calculator offers you the g of x, then also put it. If it doesn't offer you the option of the g of x, then you're going to have to draw one graph at a time. Then you go back. Then when you're done with that, you press the equal signs. It will give you the start option. So we're starting from -90. So you press -90 and the equal signs. Then the end option will come up. We're going to end at +90. And then when they ask you for the step, I believe this is optional, depending on how your graph is going to look like, okay? So before I give the step, let's see, that's our y, and this is our x. So if that's a 0, let's use 13. Yeah, I think it will make much more sense. So if that's a 30, that's a 16, that's a 19. It's a -30, -60, and probably -90. Here I can have, which one, what's the biggest number there? It's a 3. Okay, I can have 1, I can have 2, and probably 3, -1, -2, and then -3. Okay, So we said the step we're using 30. So let's use a step of 30. Then you press the equal signs, and then we're gonna just have a table of answers. So let me plot one graph at a time. Let me plot F. So let me change the color to this. So with F, if it's negative 90, then it's a 0. If it's negative 60, it's 0.8, which is somewhere there. I'll estimate that. Then if it's negative 30, it's also just the same point. And then if it's 0, it's going to be a 0. If it's a 30, it's a negative 0.8. That's a 0.8. And 90 must be a 0. No? Now, remember, this is a curve. No? And with a curve, there has to be a turning point, which is at 1 and also at -1 here. So let me connect this. Okay, it should be just smooth. The turning points shouldn't be so rough and so sharp. So that is our graph there. We can call this your F. Then let's go on to plot the G. With the G, they're telling us 0 is with 0. Okay. Negative 60 is 1.5. 1.5 is somewhere there. And then we have 2.59. 2.59 for this. And then next we have a 3. With 0, we have a 3. Perfect. And then with 30, the routine repeats itself. 2.5. We have 1.5 itself, which is somewhere there. Then we have a 0. So this is the kind of graph that we're having for the G of X. Okay, so that is G. And then this was F, no? Okay, so having done that, we have our 6 marks definitely, because we needed the intercepts, we have the turning points and all that. Then can we write down the period of F? Now, in normal senses, if the graph is just the sine of X, the period is going to be 360. But now, since there is a 2 there, which means it's going to be 360 divided by 2, which is just 180. So after 180, we have a full graph. Okay, so we're having a full graph there. So in 90 and the 19, we have 180. Okay, then they want the range of G. So with G, we can see with the range, we're talking about the Y values. The maximum is a 3, the minimum is a 0. So you can say that 0 is less, Y is less or equal to 3. Alternatively, somebody can say Y is an element of 0 and 3, something like that. And then for which values? Is the F of X, G of X, less or equal to 0? In other words, where do we find for us to have this kind of scenario, which means our result must either be a 0 or negative. For us to have a negative result, one graph must be above the x-axis, the other must be below or in the opposite direction, something like that. So the only section we're seeing is from here up to here, whereby one graph is below, the other is above. Okay, so less or equal to 0. What we do there? Let me just check my graphs again. I think I drew the graph in the wrong direction. Wrong direction. This one, because these values are negatives. Sorry about that. So that's a 0. We say it's the red, it's a negative 0.8. 0.8. And then this is going to be the positive ones. Thank you for highlighting that. So meaning that it's supposed to be something like this now. Thank you. Meaning that one is below, one is above. So it's this section that we're focusing on. So we're going to say that it's a negative 90 less or equal to x less or equal to 0. So that is what was needed with that particular question. Question number 5. Okay, this is now Euclidean geometry. They're telling us that a line drawn from the center of the circle perpendicular to the chord, this line must always bisect. So it bisects the chord. Then that is theorem number 1. In the diagram below, O is the center of the circle and AC is the diameter. Okay. AC is produced to meet ED. At point G. And then OE is parallel to CD. And then B is a 7-2. Okay. So I think we have what is being given to us. First question, they want us to get C1. Now, whenever you're answering these questions, we always need to give reasons for whichever statement that we write. Okay. So where is our C1? This is C1. But we can already see that there is a bow tie. We're seeing a bow tie there. So you're going to say that C1 is a 7-2 angles in the same segment. Okay, angles in the same segment. Then if this is a 7-2, they want us to find O1. What do you see there? So this and that. O1. So O1 is also going to be 7-2 because those are corresponding angles. OE is parallel to CD. Okay, so this angle and that angle. That's a 7-2. They want us to get D4. So this O1 is at the center, D4 is at the circumference. So this must be a half, which is going to be 3/6. Angle at the center is twice angle at the circumference. And then they want us to get the size of AED. A, E, and D. So the whole of this angle here. But one thing we know is that ACDE is a cyclic quad. Okay, it's 4-sided and the corners are basically touching the circle, meaning that this 72 and this E should be supplementary. So it's going to be 108. So I'm going to say that's 108, the opposite angles of a cyclic quad. Okay. And then if that is true, then we need to find D1. D1, which is here. We know that this D1 is going to be the opposite, no, the exterior angle of the cyclic quad, meaning that it needs to be equal to the entire size of A. It needs to be equal to the whole of A. Okay, so how many marks is that? It's just a 1-mark question. Do we have any parallel sides? Nope. We don't have any parallel sides. So what do you think we're going to do then? Let's start by finding A1. Okay. If we can get A1, But how is that going to help us if we're looking for A1? Is there a bigger triangle that we know of? Because what I'm thinking is I don't know D2. Okay, we don't know the size of D2. You don't know the size of E2, D2. So how are these parallel lines going to help us? Because I'm not seeing any sort of help with the parallel lines. Okay, so let's do this. If we get D1, D2, D3, and D4, we know that everything here must add up to 180, not so? And the only thing I know is that I'm seeing this as a diameter, meaning that all of this is a 90. I think that's going to be the only option to do. So I'm going to say ADC is a 90. Okay, angle in a semicircle. And if that is true, then I'll have a 36 plus 90 plus D1 must give us 180. Those are adjacent supplementary angles, or basically angles on a straight line. Then having done that, I can now subtract that. So meaning that D1 is going to be a 90 minus 36, which is like a 54. Yeah. Then 5.2. Can we prove that AF is the same as FD? Prove that AF, where is AF? This one is the same as FD. So the only thing you need to prove there is make sure that either F2 or F3 is a 90. If we can prove that, then we're good to go. Okay. So if D1 is a 90, it simply means that even F2 is a 90. So I'm going to say that F2 is a 90. Just write it aside and say that F2 is a 90. Those are corresponding angles because OE is parallel to CD. Now, since this is a 90, now we know that line from the center perpendicular to the chord must bisect the chord. Then just draw the conclusion that therefore AF is the same as FD. The reason is going to be perpendicular from the center of the circle. Okay. Then lastly, can we prove that OEDC? Let me just clear this out. Prove that OEDC is a cyclic chord. We say this is a 36. We found this to be a 54. OEDC. Okay, so we can just look at the opposite angles, or we can look for the exterior angle. Okay. So in this case, if I'm focusing on the exterior angle, then I'll need to look for what we are calling this side of O. I don't know if that's going to help me. But is the question asking us to prove that it's a cyclic quadrilateral? The question is asking, is OEDC a cyclic quadrilateral? Give a reason. So it's either yes or a no. Okay, so it's not a cyclic quadrilateral. I don't know. It is a cyclic. I don't know. So let's see if we can prove that. Now, we found O1 to be a 7-2. So if I find COE, okay, so it's saying that COE is going to be 108, because that will be angles on a line. Okay, angles on a line. And if it were a cyclic quadrilateral, then the whole of this should have been equal to the whole of this. But this is 108. This is like half of it. So it's not. Answer is a no. Alternatively, one would have looked at the opposite angles, because this is a 90. The whole of this is a 90. This is 108, so it doesn't give you 180. Okay, it's a no, because I'll say COF. COF is not the same as CDG. Okay, reason must be exterior angles of a cyclic quad. Okay, so that would have been also one approach to that question. Then lastly, question number 6, because they told us we have 6 questions now. They want us to complete the theorem. The tangent is ... to the radius drawn from a point of contact. The tangent is dash to the radius. A tangent is dash to the radius drawn from the point of contact. So if we have, okay, let me use this drawing. The tangent and the radius must be perpendicular. We can't say anything else. So the tangent is perpendicular to the radius drawn from the point of contact. I think that's what the question wanted. Then 6.2, use the diagram below, ABC, on the circle with OPA is a tangent. Use the diagram to prove the theorem which states that BAP, this angle here, if this is our X, can we prove that it's the same as so in other words, we are proving the tan chord theorem. So extend this, okay, through the center. And if that is correct, we can also construct that as well. Call this a D, because we don't have any Ds. Now, through the construction, we have found that we have now 2 Cs. I can call this a C1 and then a C2. Then also in the same spirit of being generous, we've divided this angle into 2. So you can have A1 and probably A2. So this should be done on your construction, okay? So what we're going to do, let's start by saying that C1 plus C2 is a 90. Do we agree? Angle in a semi-circle, because we have a diameter. And if that is true, then we know that I don't know, should I baptize something to be X? Should I call it X? Yes, I can, but no, let me just leave it. So let me look for C2. So meaning that C2 is going to be 90 minus a C1. Okay. So if that is true, then I'll come down also and say that A1 plus A2 must also give me 90. The tangent perpendicular to the radius. Okay. Then my focus is now to get the A1. To say that, now let me get the A2. So A2 is going to be 90 minus A1. But we know that C1 and, okay, we're saying C1 and A1 are the same. C1 is the same as A1. Those are angles in the same segment. Okay, so if C1 and A1 are basically the same, meaning that if this was X and then that was X, this C2 would have been a 90 minus X. This A2 must have been 90 minus X. And that, if that is true, therefore, our C2 is the same as our A2. So we're done with proving. So the main aspects, construction. After the construction, tell us that this entire angle is a 90. Tell us that this entire angle is a 90. And then draw out what you want to prove. Okay, so that is 6.2. Then 6.3, in the diagram below, PQRS. PQRS are points on the circle. PQ is produced to meet RU. PQ, okay. T, U is a tangent to the circle. PR is the same as SP. And U is the same as P1. U, where's U? That this angle here is the same as P1. So if that is X, that is also X. What is the question asking for? Can we prove that RU is the same as RQ? Okay, so remember we have two sides that are just adjacent to each other, né? Sides that are next to each other. So if we can prove that Q1 is also X, because I'm letting P1 to be X. If we can prove that Q1 is X, then we're done proving and we can draw our conclusion. Okay, so what we can see is that there's a tangent, né? And from this tangent, we can say that R1 is going to be X. Okay, R1 is going to be X. Reason, that's going to be the tan chord. Then S is also going to be X, because we know this side is equal to that side. It's an isosceles triangle. So we're going to say angles that are opposite equal sides. Okay, if that is true, we know that this is a cyclic quadrilateral. Then you can tell us that Q1 is going to be X, being the exterior angle of a cyclic quadrilateral. So if that is X, then we're done. Then tell us that since Q1 is the same as U, which is X, therefore RU is the same as RQ. The reason is going to be the converse of these sides that are opposite equal angles. Okay, so that is how we would have gone about this paper. And remember, if the first statement comes and asks about a theorem, meaning that the next questions that follow will be basically typical application of that particular theorem. Just know at least how to prove the tan chord, how to prove the angle of the center, twice angle of the circumference, and also that cyclic quad, how to prove that the opposite angles of a cyclic quad are supplementary. Okay, so having said that, I'll stop at that and wish you guys all the best in your preparations and all the best in your exams, okay? We shall meet again when we are basically going over some of the papers that you should have written. So if it's your first time on this channel and you've not subscribed, please go ahead and subscribe so that you don't miss out on the interesting information and on the new updates that will be posted every now and then. Bye-bye for now.